Boop, boop. Check, check. Let's go. Hey everyone, welcome to the Hive workshop where we will today teach how to serve and evolve your federated GraphQL API with confidence. I am myself, Laurin, and this is Kamil, and today we will guide you through the workshop. We're both leaders and maintainers at the GraphQL Hive project, and we're happy to today present you how to use GraphQL API to succeed your API story. So today we first gonna talk about schema registries and the schema history. We will talk about why schema registry is beneficial and why you might want to use one, especially if you're using GraphQL Federation. Then we're gonna talk about GraphQL gateways and how to set up one using the GraphQL registry, the GraphQL Hive registry, especially, and then also collect analytics from the gateway and send it to the schema registry. Next, we're going to talk about how we can safely evolve our GraphQL API using the analytics and information we gather on the schema registry. And then last, we will also talk about securing our GraphQL gateway using persisted documents or persisted queries using the schema registry. And then, if there's still some time, we will also do a Q&A where you can ask all kinds of questions. So all the material for the workshop will be available in this Git repository. You can scan the QR code now if you want, but be aware that you don't need to clone the code and run everything alongside me. I don't think we have the time for that. We only have 1.5 hours. So I encourage you to, if you want, clone it and play around with it as I do stuff. But maybe you should instead also just pay attention to what I'm doing, and then after the workshop, check out the code and play around with it yourself. So let's get started. So first of all, we want to ask ourselves, why do we need the schema registry and what purpose does a schema registry fulfill? So the simplest GraphQL setup you can think about is just having a single monolithic GraphQL API and maybe a single client that accesses the GraphQL API. But so questions that we can ask ourselves here is like, okay, we have our GraphQL API, we have our client. What data from the GraphQL API is the client actually using? And we can answer the question through looking at the GraphQL operations that the client is sending. We could look at the source code of the client application and look at the documents that are defined in there. On the other hand, we could also, on the GraphQL API, have some analytics code that will extract the information from the query documents that are sent to the GraphQL API. This becomes even more relevant if you have multiple clients, because as time grows, maybe instead of a desktop app, we now also have a mobile app. And a mobile app is not just one fixed version that is completely replaced every time we release a new version. No, like some people still run an old version of your mobile app, and they will continue so forever because not everyone is always updating to the latest version. Then it already gets a bit more tricky to find which fields are being used within our GraphQL API and which ones are safe to remove. In that scenario, the only thing that can help us is having analytics on the GraphQL API level. Then, if we look at something like Apollo Federation, now we don't have a single GraphQL API. We have multiple subgraphs that each define one capability or one or more capabilities that are then composed into a single GraphQL API using a GraphQL gateway. Still, on this gateway, multiple clients could access it. So, question is now, why would I use a schema registry and what benefits does it provide me in this scenario? Well, the first benefit is that it provides you a centralized schema management platform where everyone can interact with each other. You can push your analytics from your GraphQL API or your gateway on the schema usage to the schema registry. And at the same time, if you're using Apollo Federation, you can push your subgraphs to the schema registry in order to let the schema registry compose your supergraph that is then used by the gateway to spin up the GraphQL server that then the clients can query. So schema registry also serves as a space for collaborating. Like we gather the analytics on how the GraphQL API is used. We also have information about which fields belong to which subgraph in our composite schema. And based with these information, we can make strategic decisions on how to evolve both our subgraphs and also our client applications. So especially the supergraph composition in Apollo Federation is a very sensitive topic because all the subgraphs together form one supergraph schema. At the same time, if there's a conflict in one subgraph schema with another subgraph schema, the supergraph might not composable. And imagine that the gateway that runs Apollo Federation would rely on introspecting the running GraphQL services for doing the composition, and then there's a composition error. So in that scenario, the gateway would not be able to spin up the GraphQL API, and all the clients would be in a broken state. So the schema registry here helps us, as it is the central entity that manages the supergraph, accepts new schemas, and composes the supergraph. So in this example, we show GraphQL Hive. We would publish a schema to the schema registry. The schema registry would internally try to compose the supergraph. And if that succeeds, it would upload the latest state to the CDN, where then a gateway can actually pull the schema from. In the other scenario, where we would try to publish a subgraph that would fail the composition, the supergraph schema would not be able to be generated, and the upload would be skipped. And that means that we still would have the last remaining working state on our schema registry, and our gateway would not break. So the relationship between the schema registry and the gateway would be that the gateway retrieves the supergraph from there and then spins up a GraphQL API from the supergraph, and vice versa, we would report from the gateway the schema usage to the schema registry. Okay, that was a lot of words, so let's get started. So as I said, we have the Hive demo repository. It contains all the material for the workshop. Within there, we have several GraphQL subgraphs that follow the Apollo Federation spec. We have a GraphQL Hive setup using the Docker Compose file that you can spin up to have a local running GraphQL Hive instance. And we also have an example app that we're going to use in the last part of the workshop for showing how to secure the traffic between your client app and the gateway. So the first thing we're going to do is start our GraphQL Hive instance. So we go into the GraphQL Hive folder and run the command docker compose up. So this will now start all the containers. GraphQL Hive itself is quite a complex project. So while this is starting, I can talk a bit about GraphQL Hive. So it's available for self-hosting through the Docker file, but you can also create your own charts for deploying it to Kubernetes or whatever. But we also offer a cloud version that has exactly the same feature set as the self-hosted version that you can run locally or on your own infrastructure. So depending on your skill set within your company and the expertise in hosting multiple databases like ClickHouse, Postgres, and so on, you can either decide like if you want to run it yourself or if you want to run it on the cloud. Okay, so I think we should be fine. So let's visit 8080 and it's loading. So let's create a new user. By the way, it also supports single sign-on, so all the enterprise features are available. So I will just create a new account for now and and create my first organization. Okay, within that organization, we will now create a project and we're going to choose a federation project because that's what we're going to focus on today. And we will call it my first federation project. So within the project, we now have targets. Target is one stage of our development or like development cycle, staging cycle, production cycle. It's used for like modeling your flow within your company. Like some companies have multiple staging environments, some have pre-production, some have multiple development stages. So you can model your perfect flow that represents what you have already within your company with these. So for the purpose of this workshop, we're going to stick with the development target. So in there, first thing we want to do is publish a schema to the schema registry, right? So right now it's still empty. So let's publish our first schema. So publishing schema happens with the Hive CLI. So what we will first need to have is an access token that grants us access to publishing stuff. Okay, so let's go to the settings of the target, go to the registry tokens, and we're going to create a new one. Let's call it my first token. And we want to grant read and write access here. So let's create this token and copy it. Okay. So next thing we need to do is to set up the configuration for the Hive CLI. So I'm going to copy the token here real quick, and then we have the Hive example.json file. Going to copy this and rename it to hive.json. And within there, we already have it configured to point to our local GraphQL Hive instance. So now we will simply copy this token and replace this here. Okay, so now we should be able to publish our schema. So within the subgraphs folders, we have 1, 2, 3, 4, 5 subgraphs. We're going to start with publishing the GraphQL schema of the account subgraph. So within there, we have the source folder. All these subgraphs are written in JavaScript, TypeScript with GraphQL Yoga. So within the main.ts file, we have our GraphQL schema of the subgraph. And we want to now publish this to the GraphQL Hive schema registry. So I already have the GraphQL Hive CLI pre-installed here as an npm package. And I'm going to run npx hive schema publish. Then the service name, we're going to start with the account service. So let's do that. And we also need to provide the URL, so later the gateway knows where the service is running on. This one is running on port 7001. So HTTP local host 701. And then we can point the Hive CLI to this file because it's able to extract the type definitions from here. So let's do that and run our publish. Will take a few seconds and the initial schema has been published and it's now available within the schema registry. So if we now check this, maybe also increase the font size a bit, you can now see that our account subgraph is now popping up here. So then if we look at the schema history, we can see the initial version has been published. And if we look at the schema, we can see the full schema that is right now available within our API. And also we can now see the supergraph, which is composed out of the single subgraph that we just published. So here we can see the service definition, about the accounts and the URL. And also here we can see the single services schema. Okay. Also noteworthy now in the Explorer, we can also see all the types and from which subgraph these types and fields originate. Okay, so since we're doing a polar federation, let's also publish some other subgraphs, right? So the next one we're going to publish is the products subgraph. So schema publish. We're gonna name this service products, and we also need to see. So here we have the schema again. That's within the main.ts file of the service, and it's running on port 7003. So let's also publish this subgraph to the schema registry. That succeeded. Again, we can see we now have a new version of our composed schema, and we can see some details because new types and fields were added to our GraphQL API. So if we now look at the GraphQL schema of our composed GraphQL API, you can see that on the query type, the new field top product was added and the new type product was added as well. If we look at the supergraph, we can see that the new product subgraph was added there with the corresponding URL that later the gateway will use to route requests to it. And then we can also see all the fields being added that are also represented in the public GraphQL API schema. Again, we can also see our service schema. In this case, it's the product service schema. Okay, so next, let's publish the remaining subgraphs, except the echo subgraph. We will deal with this one later. So next one is the inventory and the reviews. So let's start with the reviews. npx hive schema publish service reviews and go. And the last one will be the inventory, which is running on port 7002. Okay, so now when I refresh this, we should see two more schema versions. One with the reviews, and again we see new types have been added, the GraphQL schema has been changed, and then on the last version more fields have been added, the GraphQL schema has been changed an additional time, and now if we look at the full supergraph, we can see that we now have 4 services in there. Cool. So now again, if we go to the Explorer, we should see some more fields. We now have our top products. We can see that the query type is shared by a total of 4 subgraphs. You can see that the user field originates from the accounts subgraph. You can also see that top products is from the products subgraph. If we now go within our items, within our nested types like the product, you can also see that now a lot of the fields here are shared or originate from different subgraphs. Cool. Okay. So what we just achieved is we published all our subgraphs to our schema registry, and we made schema registry compose our supergraph that we could now use to spin up a gateway. So this brings us to step 2 of our workshop, the GraphQL gateway and also the analytics. So what we want to achieve now is we want to spin up a gateway that will pull the supergraph from the Hive schema registry and then delegate incoming requests from users to the GraphQL API to the corresponding GraphQL subgraphs, and furthermore also reports the usage of the operation that have been sent to the gateway to the schema registry. One thing here is to talk about is that the gateway should use the supergraph instead of relying on introspecting the subgraphs, because if there's a conflict in the subgraphs that are being deployed, the supergraph would not be composable, and thus all our API consumers would be broken. The same would happen if one of the subgraphs would be temporarily unavailable. So if we rely on introspecting our subgraphs for composing the gateway schema, we could run into a lot of issues. If we now retrieve the supergraph instead from the Hive registry, the Hive gateway will always be able to serve the GraphQL schema to our users, and only if they send a GraphQL query that will use some of the fields of a subgraph that might be temporarily unavailable, they would be partially broken by that. Okay, so the thing that we will set up now is we're gonna set up the GraphQL gateway, which is running Hive. We're gonna retrieve the supergraph from the schema registry. And furthermore, in the next step, we will also configure the Hive gateway to report the schema usage to the Hive schema registry. So let's do that. So the Hive gateway is available as an npm package, but you can also download it as a binary and furthermore also run it as a Docker image. And same actually also applies for the Hive CLI, by the way. So for this demo, we already have it installed locally as an npm package. And yeah, we're gonna use this for running the gateway. So npx GraphQL Hive gateway. So this should be installed already. Let's run the command. Yes, we see some output here. Okay. First thing we need to do is configure the gateway to get our GraphQL schema from the schema, our supergraph from the GraphQL schema registry. For that, we have the gateway config file that we will copy and rename to gateway.config.ts. And within there, we have the supergraph section. We're gonna uncomment this. So let's go through that real quick. So the type is Hive because we want to pull the schema from the Hive schema registry. But actually, if you wanted, you could also support Apollo and other providers if you provide your special implementation for fetching the GraphQL schema from there. The next thing we need to configure for fetching the schema from the Hive registry is need to set up the endpoint and also the key. So let's quickly switch over to the Hive dashboard. In there, we need to go into the settings of our target again, and we need to create a CDN access token. Let's call it my first CDN token again, and let's copy this. And this token will now be used for loading the latest supergraph from the schema registry. So next we need the URL to the schema artifact. So for that we click on connect to CDN. We select the Apollo Federation supergraph and then copy the link to the supergraph. This URL we will enter here for the endpoint, and that's all the configuration we would need for now. So the next thing we would do now is actually start the gateway, right? So npx Hive gateway supergraph. And that's all we need to do. So we see it loaded the configuration and it's serving a supergraph from the endpoint that we provided. So let's visit our gateway. So we have our control plane. Here we can see that supergraph has been loaded. The source is the Hive CDN. And we can also see here a list of our subgraphs and which transport they are using. So let's visit GraphQL for executing some GraphQL queries. Okay. So let's write a new query. Let's call it user profile. And then we can see we already get autocomplete for all the fields within our GraphQL API of our composed GraphQL API. Let's get some name, a username, and also the reviews of the user. Of the reviews, you also want the ID, the body, and maybe also the author to cover some relations. Of this author, we want again the name, ID, and username. Okay. So let's try to execute this query. Oh, it failed. Why? Because we did not start the subgraphs yet. But as shown, the GraphQL schema is already served by our gateway, even though the subgraphs are not there yet, right? So let's start the GraphQL subgraphs. So I need to look up the command. So we need to run npm start subgraphs. So this will start all the subgraphs that are in the subgraphs directory. We can see accounts, inventory, products, echo, and reviews. All of those subgraphs are now started and are listening on different ports. So now if we now go back to our GraphQL instance and execute the query, we get some data. Nice. Obviously, if we remove a field, it will also be reflected here. Cool. So let's check again our output from the Hive gateway. You can see no output, but we can also start it in the debug mode. If we do that, we should get some more insights when we execute the query. Now we see actually the query that was sent to the server, and then it splits it into multiple subqueries that are then sent to the single subgraphs. And then in the end, the result from the subgraphs is again composed into a response that is sent to the client that initiated the request. Okay, so let's start again in normal mode. So first thing we now covered is retrieving supergraph and setting up a GraphQL API, a federated GraphQL API using the Hive schema registry. Next step would now be to report the analytics of the queries that come to the gateway to the schema registry. So on our Hive dashboard, if we go to Insights, we see that we're still waiting for some analytics data. So the next step is to configure our gateway to send some analytics. So for this, we have the reporting section in the gateway config. Again, we're going to report to Hive. And we also need a reporting token. So let's go back to our settings. We need a new registry token. And this one we will call gateway analytics. And we will again need read and write access because we are writing information to this registry. Okay, token has been created. And we will enter this here. And also everything here is already configured to point to the local Hive instance. So because we changed the config, we need to restart the gateway. Let's do that. Okay, so we can see here Hive reporting is now enabled. And actually, if we start with the debug mode, we should also see some information about the token that we just provided. So which organization, which project, and which target we would send the usage data to. Okay, so now let's go again back to the Hive gateway and let's re-execute our query a few times. And now we can see some debug output, but what I'm waiting for is the actual usage reporting. So the usage report is batched. So we sent 20 requests and they were sent to the usage reporting endpoint. So now if we go back to our Hive dashboard and reload the insights page, you can actually see that the information has been reported. And you can now see the success rate, the amount of requests, the average duration of the requests, how many requests failed, what kind of clients sent requests to the API, how many operations were sent to our gateways over time, the requests per minute, the latency, and also the single operations. And for the single operation, we can also see granular statistics, like how often has this operation been executed and how many requests sending this operation are arriving at the gateway. You can also see the full operation document. And then if we go to the Explorer, we can now also see analytics on the fields. Like for example, this me field has been used in our query. So now we can see, okay, this field is queried by 20 requests and 100% of all requests that were sent to our gateway use this field. So from this, we can already get the conclusion that we should maybe not easily remove this field, because if we remove it, we would probably break a client. And from there, we can also see, like, again, our statistics, so everything is interconnected. And one more interesting feature is that we can also see which clients use this field. So far we did not provide any client information, but we can simply specify a header here. Let's call it, it has to follow a specific name. So X GraphQL client name. So let's call it graphical. And then we can also provide the version, GraphQL client version. The version, let's call 1.1.0. And let's send this query again. And let's also send some other query, just to have some variety. So top products, we want top products, and for the top products, we want to know whether it's in stock and what its name and also its price. Let's execute this a few times. Okay. So now, after some delay, our information should have been reported. And now we can also see that the top clients, we not only have an unknown client now, we also have a named client, which is graphical, and some of the traffic is coming from graphical version 1.0.0. And if we now go to the Explorer, we can also see that the me field is used by the graphical client, and also the top products field is used by the graphical client as well. So now, if our clients would send this usage information to the schema registry or like the gateway, and we then have this information on our schema registry, if I, as a subgraph developer, want to alter the products subgraph, top products field, I can check here which clients would be affected by this change and then reach out to that team that is responsible for maintaining this client in order to figure out the migration path or get feedback on what to improve, yada yada. Okay. So now we covered both the full gateway schema registry setup. So once the first step was retrieving the supergraph on the schema registry, the next one was to send the schema usage data to the schema registry. So overall, we now accomplished this full setup where a user sends a request to the gateway, gateway reports the usage, the gateway previously pulled the supergraph from the Hive registry in order to serve the GraphQL schema, and then all the requests that are sent to the gateway are delegated to the according subgraphs. Here are some more screenshots of the Hive UI with some more data. We're actually using GraphQL Hive for monitoring GraphQL Hive. So here you can see, for example, that the Hive CLI is sending requests, and also the Hive client and Hive app are sending requests to Hive. So more operations being reported and stuff like this. Okay, so now we covered the part of setting up our gateway and collecting analytics. Next step that we want to talk about is safely evolving our GraphQL schema. That means removing GraphQL fields, adding new GraphQL fields. So altering a subgraph schema can be done in many ways. We could add new fields, which are usually safe changes, but sometimes we want to remove fields or change the type of a field or something like this. And these changes can break existing clients. There's actually two types of issues that can occur if we're changing our subgraph schema. First one would be that there is a supergraph composition error, which would break the composition. As a result, we would not be able to have a supergraph being composed, and we could not serve the GraphQL schema with that broken version. Luckily, the schema registry would always serve the latest supergraph that is composable. So if we're already using a schema registry, we can kind of avoid this issue, but in reality, we always want to avoid publishing a subgraph to the schema registry that would break the schema composition when possible. The other issue that could happen is that a schema change would break an existing GraphQL operation that is sent by a client. So those are the two types of issues that could occur when we change our GraphQL subgraph schema and publish a new version of the subgraph schema to the schema registry. And now I'm going to talk about how we can avoid having them in the first place. So here again, reminder, if there's a conflict in the subgraphs or like some issue, we don't get a supergraph. And also here I have an example of how a client could be broken by accident. So we have a schema that has a query type, we have a user type, user has the properties ID, name, and hometown, and the query operation selects those fields. Now a change would remove the hometown field from the GraphQL schema, but the query remains unchanged. So if the client would now execute this query, he would get an error. Basically, the client would be end up in a broken state. So we want to avoid this from happening whenever possible. So now I'm going to show how to achieve that using the Hive schema registry. So we already, covered publishing schema versions, but actually before publishing a schema version, we can check if the schema version that we are about to publish would integrate with the other subgraphs that are already in the schema registry. And this is called schema checks. Schema checks are also performed with the CLI. So let's get started with this. So first of all, in order to do this, we need to make a change in one of our subgraphs. In this case, I will just go to the reviews subgraph and cause a composition error. So within here, I'm going to just change this to username, knowing that this will cause a composition error. And then we will republish the review, we'll check the reviews subgraph. Okay. So npx hive schema check service reviews. Gonna point to this. So now we're gonna run a schema check using the change that we made in the GraphQL schema. Oh, we're in the wrong folder. We need to go one up. And now let's run it. Okay, stuff is happening. No changes have been identified. Why? Because this is the wrong change. Okay, let's just change this to ID because this will cause an issue. Yes, okay. Now we got a composition error. On the reviews on product type for key fields ID cannot query field ID on type product. Why? Because it's not does not exist. UPC is the unique identifier for this field. Now, if we look at the schema check, we can see that there was a composition error, and as a result, this is the service schema that we published, like the new service schema that we checked, not published, by the way. And we can see that the composition failed, thus we don't have a schema and we also don't have a supergraph. Okay, so let's revert this. So if we now publish this or check this, we get a no changes report. So that means everything is safe and this could be published. The same time, if we now add the new field here, let's call it, let's add the date to our review. And then check this, we will now see detected one change in the subgraph. A new field date was added to the type review. So if we look at this schema check now, we can see our changes, can see the change within the schema, and then also the composition succeeded, and we have our updated supergraph for the schema check. So after we did the schema check and it passed, we would now be safe to actually publish the schema to the schema registry. So we would now do schema publish, and the service would be reviews. So let's run this. And then we get our new schema version, where we now, that is now live, that our gateway would pick up, where we have now the updated schema. Okay. So basically, we just learned how we can use schema checks to verify that a change within our subgraph would integrate with the schema that we published. So for now, we just added stuff and we caused a composition error. But the other thing that we will at some point do might be removing a field from our GraphQL API. So let's see what happens if I do that. So we just published the version where we have the date field. So it's now present in our latest schema version here. So let's remove this again and then run again a schema check. What will now happen is we get an error. Why? Because the field date was removed from the object type review, and this is a breaking change. Any GraphQL operation that would use this field would be broken if we publish a new schema version that would remove this field. In this scenario, we know, okay, no operation so far used this field because we just added it. So from our point of view, we could approve it and say, hey, it's not used, it's safe to remove it, right? And then we could approve this schema check, and thus the schema publish would be legitimized. But we already sent analytics data to our schema registry. So what if instead of me as a person having to check each field that's being removed manually, whether it's safe to remove it? Why don't we automate this process using the data we have in the schema registry? Because here we already see, like on the product, on the reviews, we already can see that the date field is not in use. So why do I have to manually approve removing it? Well, there's actually a feature in Hive that can allow this, and it's called conditional breaking changes. So conditional breaking changes allow us to mark a breaking change as safe based on the schema usage data that we sent to the schema registry. So if a field has not been used for n days or is below a certain threshold of usage, we could automatically mark it as safe to be removed. Okay, so let's configure that. We go into the settings, we go into breaking changes, and we enable the conditional breaking changes. So in here we say schema change is considered as breaking only if it affects more than 0% of traffic in the last 7 days. Okay, let's configure that. And now let's rerun our schema check. So what will happen now? It will succeed. It will say it detected breaking changes, but the breaking change is safe based on the schema usage. Now, if we again check our GraphQL Hive, you can see safe based on usage and based on 35 requests that were reported for the development target in this period of time. So now it's accepted by default and we don't need to manually accept this change. On the other hand, now, if we, for example, remove a field that has been used before, like let's look for a field that has been used before, then we could remove on the product. Yeah, we use the product name, but we want to remove something on the review because that's the service that we're using. So the body has been fetched. So let's remove this. And then let's try again to publish this, check this. So what will happen now? We detected 2 breaking changes, and one of them is a hard error because the field body was removed from the object type review. So let's check the schema check for this. So here you can see field date is safe based on the usage data, but the field body affects operations that were sent by clients. If we open that, we can see the exact operation that would be affected by this breaking change. And it will also list us the clients that are affected by this breaking change. So based on this information, if we would want to go further with this breaking change, we could contact the teams and then discuss a strategy for removing usage of the affected field within the operation. Or we could say, we keep this on hold, we cannot alter this field for now because these clients are still using that. So that's basically the purpose of breaking changes, conditional breaking changes. So based on our analytics data that we send to the schema registry, we can make decisions or automated decisions and get all the context that we need for discussing changes within our GraphQL schema with our team or other teams. So the next point I want to talk about a bit is how this does fit in within your development workflow. So usually the flow that's popular with Git or all kind of providers for doing source control management is that you develop, then you push your code to your system, to your Git system, and then you have a continuous integration stuff running. So within the continuous integration, you would use the Hive schema check command for verifying that the schema integrates with the other subgraphs that are already published to the Hive registry and are already being used in production. And then you can make sure that there will be no breaking changes and that the schema is composable in the first place. Based on this feedback you get from the CI, you can talk with people from other teams, you can iterate on your code, and then make the right decisions to make sure you won't break anything in production. Then, if everything is fine within your continuous integration, you would move on to actually deploying your subgraph code to production. And this would then be done with the Hive publish command. So then, after everything is fine, the changes in the subgraph are okay, there are no breaking changes, you would publish the new schema after you deployed the new subgraph version, and then the gateway would pull the new schema version and offer the new GraphQL schema to the outside world. So in the last step now, we're also going to talk a bit on how to secure the GraphQL gateway using persistent documents. So one of the powerful features about GraphQL is that each application can craft or forge their own GraphQL queries that it wants to send that only selects the exact data that you need for the view in the application. One of the drawbacks is there that not only your apps can do that, also a malicious actor could send an arbitrary GraphQL query. And due to the nature of the GraphQL query language, this query could, for example, be very complex, very deeply nested. It could go over multiple end-to-end relations, and maybe it could be misused to DDoS your GraphQL server. So this is how usually a GraphQL query looks, GraphQL HTTP request looks like that is sent to your GraphQL API. And we can see that the query is completely arbitrary. But what if instead we send a hash that uniquely identifies one GraphQL operation that we registered at the gateway before, and thus we completely remove the ability for others to execute arbitrary queries. Well, this is called persistent documents, and because we develop our applications, or we know where the applications are developed, and thus we can know which operations will be sent to the Hive gateway, we can hash those queries at build time, register them with the Hive registry. The Hive gateway can then look up the query hashes sent from the clients, and any arbitrary queries can then completely be ignored and rejected. So implementing persistent documents is something you need to do on both the gateway level and the application level. So within the application, on the application build level, you would extract the GraphQL operations, hash those, and then publish them to both the Hive schema registry using the Hive CLI, but you also need to embed the hash within your application. So later on, instead of sending the GraphQL document, you would send the hash to the gateway. We're going to use a GraphQL code generator today to show how to extract the operations and also create the operation hashes. And obviously, we're going to use the Hive CLI for publishing the operations to the Hive registry. So later on, we will create this JSON file from our application that has some operations defined. Then we will publish this to the Hive schema registry and then configure our Hive gateway to resolve the ID hashes sent to the gateway using the Hive schema registry. So let's get started. So far I did not talk about the application that we have. So it's the example app. It's a very simple app that uses GraphQL mutation for broadcasting a message to all the clients that subscribed to the topic. So first of all, we need to set up GraphQL codegen. So let's copy the codegen file. So we will use this for generating the persisted document hashes. So first of all, we also need to configure it. So we already have in our gateway config some stuff. We will just copy this, and instead of to the supergraph, we will point GraphQL codegen to the sdl.graphql, and then we will also reuse the access key here as the header for authentication, for doing auth with the endpoint. Okay, after we set up the config, we should now be able to run the command for doing the code generation. pnpm run codegen. Oops, wrong script. So let's check the package JSON file again. Oh, it's GraphQL codegen. pnpm run GraphQL codegen. So, what's going on here? We forgot to publish the echo subgraph that will be used for this example app. So npx hive schema. Let's first check if it will integrate with our existing setup. Echo. So let's check. We see there's save changes. We added new type mutation, a type subscription, and a field echo on the type query. So we're good to go to publish this. So let's publish it. Schema publish service echo autocomplete to the rescue, and boom. Now we have some new types within our GraphQL API that is served via our gateway. So far, we did not enable polling for the gateway, so we can also do that. So now the gateway would attempt to load the newest version of the GraphQL schema from the schema registry every 10 seconds. Since we're restarting it now, it will already fetch the latest state. Okay. So now we can again run codegen on our application, and now the build will succeed. Okay, so now we go into our example app, and we will now just start the app to demonstrate what it will do. Okay, so if we look at the network tab, we can see we set up a GraphQL subscription using the GraphQL query and an SRC event stream. And now if we write something here and send a message, we can see that the GraphQL mutation has a post request with a mutation has been sent, but we're still sending the raw query. And then the event stream that we set up will subscribe to these changes and we'll add this here. So now if we also open a new tab, and we write something in here, send the message. It will also show up on any client. And this request right now happens all through the GraphQL gateway, right? Okay. So what we now want to do is to actually avoid sending this raw query here in the string and also within the operation body here. Instead, we only want to send a hash of the query to the server. And for doing this, we will enable, first of all, persisted documents on the CodeGen configuration. So this is just done with a Boolean flag in the client preset config. Just say persisted documents true. Now we need to rerun our CodeGen command. And now within our app in the GraphQL folder, we have a file that's called persisted documents. And in here, we see our both GraphQL operations that the application uses with a hash. Then if we look at the generated code, we can see that the operations now also have a hash property that's one-to-one the same hash as in the JSON file. So within our application logic, we can now, in our network layer, which is the execute function for executing mutations, use this hash property and send this to the server instead of the query string. And then in the same fashion, if in our subscription handler, which is just an SSE event stream, we will also, instead of attaching the query to the search parameters, we will just attach the document ID to the search parameters. Okay. So now, if we go back to our app and reload this, what will happen? Nothing, because we did not start it yet. So we need to go back into our example app and then start this. Now, if we reload this, we will get an error. Why? Let's check the network tab. Set our subscription. We send a hash. Ignore the undefined for now. But then we get a response, must provide the query string. And basically, we forgot to first enable persisted documents on our gateway. So let's go quickly back here. And now there's two things we need to do. First of all, we need to publish our persisted documents to the Hive schema registry. And then in the next step, we need to configure our gateway to actually use the Hive schema registry to resolve those documents. So we already got the persisted documents.json file as an artifact from the CodeGen build step. We will now publish this to the schema registry as an app deployment. So we can run npx hive app create. We're gonna call it GraphQL app, and we also need to provide a version. Let's choose 1.0.0, and then we point it to the persisted documents JSON file. Let's send this. Okay, our app deployment has been created. Now, if we check out our apps within the Hive dashboard, we can see a new app version has been published and it contains two documents. Let's check this out. Here are our documents. They are now present in the schema registry. Next step we need to do is publish the schema version. So we'll just run npx hive app publish, and we will use the same parameters that uniquely identify this app deployment. Okay, so now it's published and now it can be used by our gateway. Now the last thing we need to do is configure our gateway. So on the gateway, we have the persisted documents section here. We're going to use Hive as the persisted documents registry provider. And for the endpoint, we're going to use this part of the URL. And then for the token, we can also just reuse the key that we use for the supergraph because they're served over the same CDN. Okay, So now we need to restart the gateway again because the configuration changed. Oops. And also the last thing we need to do within our app is we need to configure the version. So within our index.html file, we have a global variable that is set, and it's the app version. And in our case, it's the one that we use for creating the app deployment. So it's GraphQL-app tilde 1.0.0 tilde. And this is within our network layers being attached to the string. Why? Because the operations are stored in a namespace within this Hive schema registry to not clash with other applications. Okay, so now our gateway should be up. It will say something like using persistent operations, hopefully. Blah, blah, blah. Yes, persistent documents enabled. So now, if we go back to our app and reload this, we will first see we send a request and it's running. So if we now check out our network tab and reload, you can see that we sent the document ID with the composed ID out of the app version and the hash to the server instead of the GraphQL query string. And then we can also see that the event stream this time does not yield any errors, and it's safe to use the app. So now if we send some messages here, it will show up and it got sent over our event stream. Same time, if we look at the post request that we just sent, we look at the payload, we can now see that we're also sending the document ID instead of the raw query. And it's still accepted by our server because it now uses the schema registry to resolve this document to the actual query, this document ID to the actual query document that is then executed. So if we now go back to port 4000 for graphical, we can still see that we can, we basically disallowed executing arbitrary queries now. So within our gateway config, we could still specify allow arbitrary documents true. And if we do that and restart the gateway, we would again now we would again be able to execute arbitrary queries, but as soon as we remove this, the gateway will now only accept executing the persisted documents. So if we do this, we should get an error. Yeah, no persisted document provided, and our app is still functioning because it uses the persisted documents. Yep. Okay, cool. So again, like the schema publish and schema like the schema check and schema publish comments, you would integrate the app create and app publish comments within your app deployment workflow. So similar to how you iterate on your GraphQL subgraph, you would integrate these steps into your CI for iterating on the apps to make sure that every app before it's being deployed has their documents being published to the schema registry. So later on, the gateway can resolve the document IDs to the corresponding operations when requested. Okay, so this is basically now the end of the workshop. We covered a lot of stuff. So now we still have some time for questions. But if you want to dig deeper into GraphQL Hive and all the features that it offers, you can just check out the GraphQL Hive documentation. You can later on come to our booth. We can talk a bit more about like self-hosting, cloud hosting, and stuff like this. So feel free to reach out, and thank you for your time.